to no audio. Sean, can you hear me?
Yes, Chris. Can you hear me?
Jolly good. I can hear you loud and clear. We're almost professionals at this nowadays. Yeah, I'm good, thank you. How are you?
Yeah, fine, thanks. Yep.
Cool. Have you still got? You said you had hot weather where you are, didn't you, earlier on?
It was hot earlier on in the day. Kind of in the shade now. So
Yeah, it's moderately warm. I just got my daughter from school, and it was moderately warm here as well. All right, well, let's get stuck in, shall we? So this is episode 5 of Calico Live. Calico Live is an occasional informal live video stream series where you can kind of relax and check in with us. It's an opportunity for us to go off script a little bit and chat about things that interest us and that interest our users. We have been focusing on the eBPF data plane in these sessions, but this will be the last session where we focus mainly on the eBPF data plane, and at the end of today's session we'll talk a little bit more about what comes next. We do publish an agenda ahead of time, but we actively wish to be interrupted. So if you have any questions, I've got my YouTube chat up here. If anyone has any questions or would like to deep dive or ask something entirely off topic, that's totally fine. We never quite get as much interruption as I would like. I would thoroughly enjoy being interrupted, so if anyone would like to, they'd be more than welcome.
careful what you wish for.
Say again, Sean?
Careful what you wish for.
Yeah, I know. Yeah, one day I'll get a big one. No, I think it's good. So it's meant to be a less structured session than for example, the laser sessions or anything like that. So yeah, with that said, let's get stuck in. I'll just do my introduction. So I'm a developer advocate at Tigera. My name's Chris Tompkins. I kind of champion user needs and support our users and our developer community. I've been working in networking for around 20 years, which has gone in the blink of an eye. Sean, do you want to do your own introduction?
Yeah, sure. So I'm Sean Crampton, distinguished engineer at Tigera. I look after a few of our components, including the BPF data plane and our regular IP tables data plane, and a couple of other things besides.
Fantastic. So just looking at the what we've got written down as our kind of vague plan, I said we'd conclude a few things that we didn't get time to talk about last time. So if it seems like we're jumping in randomly, that's kind of to follow on there. You'll recall we were talking about BPF and XDP, and the last thing I think we talked about was the features that had made it into 3.20. And there are a few questions I had about XDP that we never got to, and I thought we could start off with those, if that's okay.
Sure.
Cool. So one I thought was quite interesting was I think we talked about XDP for the purposes of denial of service mitigation. In fact, I'm pretty sure we did, because you were telling us about the fact that you don't really need to store state and all that, because denial of service mitigation is kind of stateless at that layer. So I remember that part of the conversation. So I think we talked as well about how XDP can be implemented in the hardware or in the driver or in the kernel. And I just wondered if there was a way to get visibility that you're aware of where those rules. I'm sure you can do that if you deep dive, but is there a way for a user to be able to understand where those rules are being applied?
I think that's quite simple. If you just run the command ip-link on a host that has an XDP program installed. So let's say your main interface is called ETH0.
Mm-hmm.
If you run ip-link and then find the entry for ETH0, it will have like a keyword XDP in the line, and I think it has, just after that, it has generic driver or offload, if I remember correctly.
If you want to go and get some water, feel free. Okay, that's actually quite useful. I have a feeling I'd seen that there before and not fully connected the dots on what that meant. So that would tell you if it was in. Does that make the distinction between the driver and the hardware though? I'm betting it probably doesn't, because the OS doesn't really get visibility of the hardware. Is that fair?
No, the modes are distinct. So it's not that you hand the XDP program off to the driver and then it decides whether to put it in hardware or not. You have to ask it to put it in hardware. It's a long time since I've used that command.
Fair. That's totally fair.
I remember it spitting out some useful information like that, but I can't remember which one.
Yeah, that's fine, Sean. And honestly, I probably would have had a cluster ready, but I knew that we would only be briefly talking about this, so I didn't seem quite worthwhile to bring up a cluster specifically for just a couple of questions. That's fine. I will dig into that after the session, and I'm sure you've given anyone watching enough information to find out for themselves. So the other thing I didn't feel entirely clear on, which I think we kind of alluded to, was both in IP tables mode and in BPF mode. So let's talk about IP tables mode first of all, because it's the simpler case. In IP tables mode, am I correct to say that the only use of XDP is denial of service mitigation? There's nothing else, right? That's
correct. So the way that works in IP tables mode is you create a policy, and if you create a policy that has an ingress deny rule and do not track policy, and it's the very first policy in your list of policies, then that single rule in that single policy will get accelerated. It has to meet all the requirements. The reason we did it like that is because if anything's like not quite right, we still implement the rule correctly. It just goes in IP tables instead of XDP. So we didn't want to introduce yet another type of policy. Calico has enough of those already. I think everyone will agree with that, who's tried to use all the types of policy that Calico offers.
Yes.
So we didn't want to introduce a separate like XDP offloaded policy, or whatever we might have called it, because that would just add another layer of complexity into the data model.
Cool.
So yeah, to activate that feature, you create a policy of a particular form, and the policy will be correctly implemented whether it gets accelerated or not. But obviously, you want it to be accelerated if you're doing that.
Great. And then in 320, that same feature appeared in the BPF data plane, the eBPF data plane mode, didn't it?
Actually, it's a bit more capable than the IP tables.
Oh, okay.
There. In BPF mode, we already have a BPF policy engine rather than in IP tables mode, like way back when, we didn't have a full implementation of Calico policy in BPF to rely on. So we built a minimal BPF program that could only do that one thing to apply to the XTP hook. But when we're in BPF mode, now that we've added that feature, we have a full implementation of Calico's policy rules, so we can implement any set of do not track policy as long as it's all drop rules. So the allow rules will be ignored for now, and the packet will just fall through. That's already been addressed on master on our like main branch that's going to be in 321. So Calico 321 has the full do not track semantics.
Just to be clear on that, that's 321, not 3.20.1, right?
Yes.
Okay.
Yeah.
3.20.1 has nothing new from our perspective, does it?
I think that's right. Yeah.
That for the purposes of the. Great. Okay. Cool. We just had a user say hi, Vinesh. Hello. Hi, Vinesh. Do you have a question for us? We'd love a question. As you can probably tell, if you've got any questions, shout them out for us. It might take me a minute to notice it over here in my field of view, but I do look over there. Okay. Great. So that's really helpful. Thanks, Sean. So there are a couple of other things here, but I think we should push on and talk about the other thing that we're going to spend some time talking about today, which is the status of eBPF on the eBPF data plane on ARM and where we are with that. There are a couple of blog posts that I think are appearing very soon, but I believe haven't yet appeared, kindly written by my colleague Reza Ramazanpour. He took an interest in revisiting eBPF on ARM. Now, the official state in the documentation is that eBPF on ARM's simply not supported. But in actual fact, which I'll probably try to demonstrate in a moment, it does actually work. So I just thought maybe we could take a moment to just say what is the status of it as you see it today.
Yeah. Before Reza submitted his patches, it didn't work. I know it didn't work because there were some changes that were needed to build the BPF programs for ARM and add them to the Calico node image. So it was actually disabled in the code, and I think one of the things that Reza did was get that build working and then re-enable it in the code.
Fantastic, yeah. And the reason, so I suppose let's before we talk more on what the ARM is, let's talk about why it's a thing that we might even care about. Some users this will be very, very obvious, and some maybe not so much. So I think we should probably take our time to drill into it. So there are many kinds of processor, and they are based on different architectures. And the dominant server architecture for a long time for conventional data centers has always been x86. So PC architecture, and we've kind of got used to that for such a long time that for a long time it wasn't even a question really. I can remember deploying some large IBM mainframes in a previous job, and that being a really, really unusual thing. Everything else I've ever deployed has been Intel, including the switches that I was plugging them into, or at least the control planes of them. But that's finally starting to change, and that's because ARM is a different processor architecture, a RISC processor architecture, and I don't want to drill too much into that because it's kind of quite off topic, but broadly, these chips run a lot cooler and a lot cheaper, and in terms of price performance, I should say. Although I think it's do you know if it's fair to say that in terms of actual extreme performance, I think it's still probably x86 processors that are winning that fight? I'm not going to hold you to that. I think the answer is yes.
I think the answer is yes, but then people have been making a lot of noise about Apple's new processor.
Right, yeah.
I don't know if that's available on the server side yet.
Not to my knowledge, but like you, I'm not.
Played with it myself, but they were saying that had outstanding performance. It's really hard to compare different processors because it's all dependent on the workload.
Yeah.
One of the tricks that they often do is, if you have an ARM, because an ARM processor is smaller, well, you can put twice as many on a chip. So now, do you have twice the performance, or you only get twice the performance if your workload is suitable to be broken up into many concurrent workloads for multiple processors to use. So I don't know.
Yeah, no, that makes perfect sense.
They're pretty competitive, and certainly for some workloads.
Yeah, and anecdotally, when I used to go and install routers and switches and networking, in racks, and the number of racks in data centers in the UK that are half empty because the physical space is not the limitation, the power and cooling is the limitation. That's why I think this is something that that just makes logical sense in the longer term, because if we can get racks and actually fill these racks and not run out of power and cooling before the physical footprint runs out, it seems like something that we would want. Having said that, that kind of leads in nicely. You were telling me when we were chatting about this earlier about the status of this, and I think it's fair to say that where we are at the moment is largely that there's no huge demand for it that we've received for specifically, I should be more clear, for specifically for Calico's eBPF data plane on ARM.
I would say people have asked about it, handful of people. I guess like 1% of the queries we get, so it's enough to notice, but it's certainly not the main market. We'd love to have it sort of well supported in the product. On the IP table side, like before we added BPF, so we got contributions from the community. So in particular, like I believe ARM pay a team to contribute into open source projects to bring ARM support to them. So they did the initial work to get ARM builds working, and we've just kind of made a best effort to keep those going. We do all our builds on x86, so we do a cross build and build ARM images for the various for the main components of Calico. I would say where we're a little bit behind is we don't have test infrastructure that can put all those images through their paces. So we can fairly easily build, but we don't have an environment where we can run all those images. However, there are people in the community that care, and I think the ARM team that originally set it up, they were doing builds and kick the tires testing to make sure it wasn't totally broken, and they had a bit of CI on it as well that was doing kind of regular builds. I'm not sure if that's still active, but we certainly want this to work. But I wouldn't say it was like top priority for the core Calico team. But we've had a bunch of community contributions.
Yeah, that's cool. One thing I'm taking away from that's quite positive as well, though, is it sounds like it wouldn't be an enormous undertaking. It doesn't sound like there's any kind of technical blockers. It's more about I don't want to use the word productizing it, but making it something that can be relied upon and is being tested reliably and so on. It's more about integrating it into the process than it is about it being a technical limitation of any kind.
Yeah, I would say the core product is kind of very portable. Golang is a very portable language, and and that's what we use. It basically just works to compile Calico for ARM, without really changing anything. There are a few places where other architectures are more tricky. So ARM in general is a little endian system like x86. Most people run it that way. So, compiling it, if it compiles, then it basically works the same. If you switch from x86 64 to ARM 64. One that's slightly more difficult is PowerPC and S390X, which are the other two architectures that we have some support for. Again, teams from those respective environments contributed builds for those, and those are a little bit more difficult with BPF because they're kind of big endian systems in general. So we would need to audit the BPF code, make sure we've got all the endianness right. The code is designed to handle it, but the first time you run it on the opposite endianness, you're bound to find issues. So
yeah, that's something I totally understand the concept in the sense of it's which way round your most significant bit is, right? But I've never actually had, although I understand the conversation, I've never actually had to do that myself. But I assume that there's no way to instantly know that you're seeing the right set of bits. Is that the problem, that you might end up with the wrong number because you've got the most significant bits rather than least significant bits? Or
it's actually the most significant byte. So you don't usually see any impact within the byte because they're always you always have the most significant byte on the left. The most significant bit of a byte is always on the left, I think, when you're programming. But it's that the byte order is swapped for a lot of operations. So if you're treating something like an IP address as a 32-bit integer, like an IPv4 address, then if you copy that from like a packet, it's big endian in the packet, but then if you send it up to user space and the Go binary is compiled with the opposite endianness, or if you're copying bytes in and out and shifting them to get them in the right place and that kind of thing, like all those operations need to be correct.
Yeah, that sounds quite gnarly as well, because I suppose with an IP address, it's not immediately obvious, unless it's like an RFC 1918 address. It's not immediately obvious if things have been put in the wrong order because it still looks like an address, I suppose.
Yeah.
We just had a question from Nathan on the chat. He said, do we expect any performance difference for big endian versus little endian? Well, I don't think let me have a go at that, and then you can tell me the proper answer. I'm assuming it wouldn't make any performance difference in the sense that once the code was if you were porting to a platform that required it, once the code is ported, it shouldn't make any difference. Is that right?
I think that's right. So I wouldn't expect any performance difference from like fixing any endianness issues that we have in there. However, I think most of the BPF work in the kernel has been done on x86. So I would be surprised if the BPF virtual machine running on ARM and PowerPC and S390, I would be surprised if those are as heavily optimized and as fast as the version that is in the x86 port.
Right.
So the BPF programs get compiled to BPF bytecode that is loaded into the kernel, and then the kernel either interprets that bytecode like one instruction at a time, or it does a just-in-time compilation where it compiles it to equivalent machine instructions and executes those. The latter is much faster, but the BPF virtual machine, I think, is somewhat designed with the x86 one in mind, and ARM is similar enough. I think that one's probably efficient.
Right.
But I don't know. I
Yeah.
don't know.
Oh, that's fine. Don't know is a perfectly valid answer in a lot of situations, I think. Nathan, if you have any follow-on questions, feel free, and if not, you can always join us in Calico Users, and we can dig into that more for you. If it's just a point of interest, we're still happy to take that and find an answer for you. So I suppose the only other reason, I was just looking at my kind of discussion around reasons for wanting ARM. Obviously, the price performance and the thermals are the main thing, and rack density. Support is much better than it ever used to be. But the other thing is the prevalence of Android and mobile phones as well. I think there's an argument to say that if your end environment, if your target architecture is ARM, which is far more likely than it ever was before, then it might make sense not to do your development in an interpreted environment of some kind, but rather to do it on a real ARM server. Which that's certainly, when I was digging into this, that was certainly a put forward use case. If you have any thoughts on that before we dive into it, after that we can dive into a quick demo. I think I can get it working.
Yeah, I mean, I guess that could be useful. I guess that would be an argument for having your desktop be ARM, like more than your sort of server, unless you're running. I guess if you're running builds for ARM on there, then
well, I imagine. Yeah, that's an interesting question, because whether people are developing mobile apps on. Whether people aren't developing mobile apps entirely on local desktop, or whether that's... I mean, certainly I think you probably could have said that was the case a few years ago. I don't know nowadays. I suspect they may have changed a bit. Nathan just made...
I guess
sorry.
Your overnight builds of your app are going to be easier if you're not cross-compiling everything.
Yeah, yeah.
Or running an emulator all the time. Yeah.
Yeah, Nathan just made the very valid point, I mean, which kind of goes to what we were talking about earlier, really, but that AWS has a huge price discount for ARM in the cloud. I shouldn't say huge because I don't know the exact number, but yeah, I was looking into. They have that special processor as well, don't they? What's that called? Come on, Google, help me out. They have their Graviton. That's the one. I'm not going to pretend to know much about it other than that it's custom built ARM CPU. So yeah, let's dive in then and see it working. It won't be the most exciting demo ever, but hopefully this will work for us. I actually had some personal stuff going on just before this call that meant I didn't manage to test it as recently as I would have liked to, so this might be exciting. But that's fine. Let's see if I can get the right window share for a start. So that one. This probably won't be very readable for you, Sean, but I'll whack the font size up. It should be readable for our viewers. No, that's the wrong one. Can you read that as it?
Yeah, I can make that out.
Oh, great, fantastic, good, okay. So really, this is just going to be a really quick, simple thing. Incidentally, I can't now see. I'll just bring my chat window back up. Yeah, there we go. Okay, great. So I just thought it'd be a nice thing to actually see, and we've got a Terraform file here. No, not state. I wanted vars. And you can see the image ID is this ARM image, and it's running on an M6G large instance.
G will be your Graviton, is it?
Yeah, exactly, yeah. Now, Reza, who might be on this call, who actually built this originally, said that there was a nuance around the availability zones, and it needed to be limited to two AZs rather than 3. I'm afraid I do not know why that is. It may be that Reza is watching this and chips in, and if not, I can answer that later. So yeah, so we'll just do a quick Terraform apply. Gosh, that's quite a font size.
It'd be wonderful if Reza could contribute all of this into our internal CI system, Chris.
Yeah, I think with a gentle shove, I reckon he probably would. So yeah, it'd be really nice. It would be really nice to tick that box, and I think, well, my personal view is we're going to end up wanting to do it definitely at some point. It's just a case of at what point it becomes, obviously the amount of resource that we have has to be deployed in the different tasks. But I think at some point we're definitely going to want it. And being able to build it like this kind of shows that we're so close already. So if I take the instance, so we've got 2 instances here incidentally, and they're running K3S. Hence, there's no need to remove the taint from one of them. But I'm getting ahead of myself. Sorry, they're not running anything yet. If I jump onto the first instance. So at the moment, these are just vanilla instances. And if we look at uname -a, you can see that they're ARM. And we can install K3S using this command, which is the usual piping curl into the shell. I'm just looking to see if there's anything we should particularly remark upon here. I think disabling traffic and disabling network policy, I believe Reza just did this to keep things simple. There's no reason that those have to be disabled, I don't think. So that's installing K3S on the first node.
I think disabling policy and flannel is so you don't get K3S's built-in policy and flannel, as we want to install.
Yeah, that's right, isn't
Calico.
it? So that one. Sorry, I'm highlighting on the wrong screen. Sorry, it's been a long day. So yes, that's right. So disabling flannel and disabling network policy so that we can then go ahead and install ours, isn't it? And disabling traffic is as I said, I believe. Okay, yes, good point, thank you. So we should find
traffic is I think it's traffic, might be traffic, is a ingress controller.
Well, that's it. That's a whole interesting can of worms. There's a few things that you and I disagree on the pronunciation of, but I think we get on so well, I don't think we should discuss them. There's one other that we'll talk about later. Right, so there we go. So there's our 3.
My accent is firmly in the mid-Atlantic after living in the US for a while.
Yeah. Oh, did you? I actually didn't realise you lived over there.
Yeah, I flip-flop in the same sentence. I'll flip-flop on different words.
So neither of us can be trusted then, because I grew up abroad as well, so I've got a few weird ones in my vocab, as my ex-wife used to tell me. So how long did you live over there then, just quickly, jumping subjects?
5 years.
Really? And whereabouts was that?
San Francisco and Palo
nice.
Alto.
Oh, very nice. Oh, we'll have to talk about that later. Cool, alright, so you can see that in the meantime, that's finished building, and we've got 3 pending pods, which are just waiting to start because they've got nowhere to start. Or we should have. Actually, it's not they've got nowhere to start. They haven't got a node that's ready for them to start on, I should say. So next thing we can actually do is to grab the usual Tigera operator manifest, and then put it into sed and look for the string operator master and change that to operator master 64. So if we have a quick look at that file now, all that's done is it's just the vanilla version of the file. Let me look for that again. ARM64. Yeah, there we go. It's the vanilla version of the file, but we've changed the Tigera operator image, so it's pulling the ARM64 version of the operator. Oops. So we can now actually apply the YAML And we're not applying the version, the unmodified version from the web. We're applying that version that we've changed the content. So that's the operator deployed. And then, as you normally would deploy the custom resources, instead of doing that directly, I've created a new file called default installation. And this is identical to the custom resources file, except it's missing the API server. And I believe that's because the API server isn't ARM64 ready at this point. Do you know any more about that, Sean?
Yeah, I just don't think we have a build of that yet. But it's an optional component for now. So,
yes, good point. Yeah, I should have made that point.
And maybe Rez is working on it anyway.
Yeah, we can ask him about that after we come off.
I expect that one would be a trivial one to port because it's just a Go binary. So
yeah,
probably just a matter of building the ARM64 version. It's a fairly new component, so maybe we forgot to include the different architectures when we spun up its repo.
Cool. So if I apply that, then I can keep an eye on the rollout. So we're just looking for the status of the Calico node daemon set to finish in the Calico system namespace.
So I think Rez has gone a little bit further than what we had before. I think before we had like Calico node, like the per node component ported to ARM. I think maybe he's set up a build for the operator and some of the other components so that you can have a sort of completely ARM cluster with no x86 nodes to run things.
Yeah. Yeah, that's pretty fantastic. So there's a token which I'm going to be sure to delete this cluster the second we get off this call, so we don't need to worry about that too much. Jump off there, and if I quickly jump onto the second node now. Gosh, I have to scroll back a long way. Okay, so now we're on the second node. We can just run the normal curl command that allows you to join a running cluster, and I just need to stick that token in. So you can see that it's pulling a script from K3S website, setting the version, setting the URL. I nearly missed the IP address, and that's the first private IP address. Sorry, it's the private IP address of the first node is what's needed there to tell the second node where to find the first node internally. Okay, that should be it. So if I jump back to my local desktop and then SSH back across to the primary, I'm always paranoid that I've jumped onto the wrong node because I did that once in a demo and broke everything. So I just came off 2.6 and I'm now I'm definitely on the other node. Yeah, there we go, great. I thought I might be able to see here that this was a ARM node, but let's see if I can do that by describing the node. Because we're waiting for it to become ready anyway.
Have you applied Calico on there already yet? You applied the operator?
Yes, I did, yeah, exactly. Yeah.
There's no OYAML on describe.
Oh, is there not? Oh yeah, of course there isn't. Yeah, you're right. Sorry, my bad, my mistake.
I think it gets a label, if nothing else.
Arch on 64.
There you go. Yeah.
There we go. Perfect. Great. Cool. All right. So while we've been doing that, we should now find that we can see it is ready. Yeah, and it is. Great. Okay. So let's go ahead and, in the interest of time, let's jump straight on to actually enabling BPF. So I can do this. So the first thing I need to do is as usual, to point it at the endpoint. So there's the endpoint IP, because we don't want Calico to talk to the kube proxy. So I need to edit that.
Yeah, so when you're in BPF mode, Calico takes over from kube proxy. So like kube proxy, Calico needs to know the direct IP to reach the API server. In a simple node like the one Chris has here, in a simple cluster like the one Chris has here, the API server is just one of the nodes, so we're just using that IP. But if your cluster does have kind of a load balance or a HA API server, you want to use the IP address of your load balancer there, because the IP address of the particular instance that we're using here is kind of transient, and if you restart that node, you might get a different IP and things will break. So just to flag that up, this is okay for testing.
Yeah, thank you for pointing that out.
For that on a real system.
Yeah, so I've just created that config map, and I'm just going to delete the Tigera operator pod to make it pick up that change. But I've put a sleep 60 on there.
I think that's not needed
anymore. Do you know what? I suspect I may even have said that on these sessions before, that I think that may be one of those things that has hung around and will end up being a bit like a rabbit's foot, where people do it because they feel like they once needed to. Yeah. I think we've all been in IT long enough to definitely know those processes where someone thinks something needs to be done because it once did, and I think I'm guilty of that. I think I still do it because I know I used to need to.
Yeah, I think it does pick it up. But,
yeah. Do you happen to know what version that changed in?
I think it was maybe 3.19, but the operator has its own release cycle actually, so I'm not sure. Not sure what version that would be.
Cool, that's all right. All right, so let's break with tradition right now then. And I broke out of that without restarting the Tigera operator. So I'm exporting my kube config, and I'm doing that just to allow Calico Kuttle to be able to talk to the API. So I'm going to download Calico Kuttle from GitHub. It's the latest version, but notice that it's the ARM64 version of Calico Kuttle, making that executable and then sticking it into user local bin. So if I've done that right, then yeah, then I can now run Calico Kuttle. And because we're running K3S, we can't disable kube proxy. So instead we do this Calico Kuttle, we're patching the Felix configuration to tell it to stop tidying up stop tidying up kube proxy's own IP tables rules. Did you want to have a better shot at explaining that than I do, Sean?
Yeah, so by default we assume that kube proxy isn't running if you're in BPF mode, and just as a convenience feature, we tried to clean up kube proxy's IP tables rules in that case. So if kube proxy really is running, then that cleanup will fight with kube proxy, adding the rules back, and then we'll delete them and so on. So yeah, you're disabling that feature. Actually, I said it's a convenience feature. Like if kube proxy isn't running, it is important that we remove those rules. Otherwise, you can get bad behavior as the IP tables rules go stale. You might have IPs that are in IP tables, but they're not reflected in Calico's
interesting. Okay,
service.
That's worth knowing.
Or vice versa, and it can get confusing if you do that.
That's what really. That I just learned something then. Actually, I didn't realise that. I thought it was just a convenience thing. So I just thought I'd highlight while we're here actually that I'm needing to use this allow version mismatch because we recently made it so that Calico Cutter will point out when the client and cluster version are mismatched, which I think is a really good thing overall. So I just add that extra flag in, run the command again, and I've patched that. And then the last thing is to actually turn on the BPF data plane. So we can have a quick look at we should see the pods restarting now for Calico node. Yeah, we are literally, one's restarting right now. So in theory, when switching to BPF, it's non-disruptive, right? How does that work if Calico node is momentarily restarting?
So Calico node by design is not on the data path. Like packets don't flow through Calico node.
So it's the control plane data plane thing that we've spoken about. Yeah,
exactly. They flow through the kernel. So Calico node restarting means that we can't update the data plane. So if a rule changes, we can't do anything because we're not running. So that makes sense. But Calico node restarts, and then it will spot it's in BPF mode. It will add the BPF programs. And the BPF programs are just designed so that they spot traffic that they don't recognize, and they give it a second chance by passing it to the kernel to do its normal thing. So if your traffic is has some contract state because it's known to the kernel, then it will get that second chance and it will go through. So that's just a pragmatic approach to falling back to the kernel if the BPF mode doesn't. Is there
any limited amount of time that it can be headless? Or is there anything that times out after a certain amount of time? Or
I don't think we do time that behavior out. It might be good to have a mode where you can say you don't want that, so that we're more tightly locked down.
Yeah.
And there's fewer things that could go wrong.
Interesting.
But we haven't done that.
Cool. Okay, so I've cloned. This caused me much confusion because, of course, the benchmarking suite that we most commonly use needs to be recompiled as well. So Reza has kindly done that. But when I was originally building this test, I didn't realize it was not in the master branch, so I just have to grab the branch name. Yeah, there's an ARM64 branch here. And I think we should be able to send some...
Is it worth checking that BPF programs are really installed? And
yeah. Remind me the syntax, though. I don't remember it.
Do you have TC installed on this node?
Yeah,
so if you do TC qdisc show, that will show you a qdisc. So you've got some class act qdiscs. That's a good sign.
Mm-hmm.
And if you do TC filter show dev and then pick one of your Kali interfaces. So the name,
there they are. I see them. Yeah, TC filter.
Name of one of your Kali interfaces. I think that's it. And then ingress. You need to put ingress or egress on.
Yeah, because I remember you showed me that, and it's really obnoxious that it fails silently, or not fails, but that it doesn't send anything if you don't have that switch. It'd be nice if it could tell you. Okay, so that looks promising, doesn't it?
That's a good sign. Yeah.
Yeah, great. Yep. So we appear to be running that just fine. And I think all we need to do then is blast some data across. Now, obviously, we're not particularly drawing attention to the performance here. We're just showing that it works. Or it would do if I had the right command. Oh, yeah. That's got to be CN. Try that. Now, usually, if this wasn't K3S, you'd need to remove the taint from the master node to allow something to run there, but you don't need to do that in K3S. As I must admit, I didn't actually realise.
This tool was written by Alexis
DeCastro, yeah, and it's fantastic. I use it so regularly. I think Rez has actually raised some PRs against it as well to make a few tweaks as well, hopefully. I think this is to do with it's not understanding how to parse the processor architecture properly. So it's cosmetic is what I should be saying.
So I think the tool, you told it to have a server node and a client node, and then it runs an iPerf session between pods running on those two nodes.
Yeah, exactly.
Remember, and it spins through all the different types of iPerf that it can run. So UDP and TCP and UDP via a service, TCP via a Kubernetes service, and so on. Yeah.
So as you can see, I think that doing that process, or actually, I had to learn how to do that ARM build, but it is kind of reassuring how few tweaks there are necessary. Really, kind of shows that as you kind of said right at the start of the conversation about it, it's really just a case of putting the bow on it. Or I don't want to trivialize the work at all, but the majority of the work has been done. But yeah, I think Reza probably can be encouraged to pick up the rest of that work. I think he'd probably quite enjoy it as well. So let's see if we can gently make that happen. Let me just have a quick look at the plan, because as usual, the time just flies in these sessions. I don't know where it goes. So I'm just looking to see if there's anything we really need to talk about. Oh, now that's interesting. That didn't happen when I ran. You know what's interesting about that, Sean, is you can see it ran, that the idle node completed successfully. Then it started the TCP node, which completed successfully. And the UDP node completed successfully. So failed to run pod KMB client TCP.
So that's TCP pod to
service. That's really interesting that the TCP client pod to service started. Can you just run that one more time? Definition of insanity, that running something twice and expecting it to work differently the second time. I will say though that
maybe we have a bug there.
Yeah, it could be. I ran this a few days ago and didn't have that issue. That's interesting.
Forget exactly how to sort of debug the KMB tool, but can always sort of figure out what commands it's running and manually run an iPerf session to see what happens.
Yeah, what I'll do is I'll leave the cluster up and do that after. Although actually saying that, I did have that token on screen earlier, and that makes me not want to leave the cluster up for more than this session. I think I'll delete this. I think I'll delete this and see if I can recreate it privately tomorrow. It doesn't feel like a great idea to leave this cluster up after we come off this call, I don't think. All right, well, let's leave that running. But since we're running low on time, the only other two things we were going to talk about, the first one really is Calico Live and where we're going to go on forward from here. We're largely finished talking about eBPF on this run of chat talks, although obviously if something comes up that's of great interest, there's no reason we can't either have you back on or just talk about it separately. It's been amazing having this time, and I've learned quite a bit. But in the same way that having you on here has been amazing and a benefit, and I'm grateful for it, we have Casey Davenport is likely to join us for a couple of sessions after this. And Casey is the principal software engineer of Calico. So I'm really excited about that, and I'll be able to get a kind of bother him with equally stupid questions and hopefully get equally interesting answers. So I'm really excited about that, and I think when he first comes on, we're going to be talking about he recently added some functionality for service-based policies. So we're going to be talking about that and probably doing a demo of that and chat about the implementation. So I'm quite excited about that. I'm looking at this and I don't know why that's happened. I don't think we're going to be able to fix that on this call. So I think we'll just take that offline. But what I might do actually is, in fact, what I will do is at the start of next session, if I arrive at any interesting conclusion about the issue that was underlying this, I'll pick it up. Could just be the demo gods though, because I didn't have that issue. Or what? What's your instinct, if you don't mind me putting you on the spot?
It's since it's going to a service. I don't know. Can't immediately think of anything in an ARM port that would be different there. But yeah, we can. I think there's a debug setting on that tool where it will print the actual output from the container, which might give us a clue.
Yeah.
And then like we can look in the BPF logs to see what happened to the packet.
Yeah, that might be quite interesting actually. All right, we'll do that. And I just had a quick look. None of the pods are restarting. Everything appears healthy. So that's quite interesting. Yeah, so I'm really excited to have Casey on board afterwards. Since we're running a long time, I just wanted to say, Sean, I really, really appreciate the time that you've taken. I'm sure everyone does who's watched any of these sessions. And like I say, I've learned a ton, so I hope it's been interesting for you in some sense.
No, I've enjoyed it. It's been fun to talk technical on one of these things.
Yeah, I think someone said to me a long time ago as well, you don't sometimes talking through things out loud is both beneficial in terms of appreciating what you do yourself know and being grateful for it, and also sometimes it allows you to understand things at a deeper level when you try and explain them. There's a famous quote about that, isn't there? If you can't explain something to someone else, then you don't really understand it. Something along those lines. I'm just going to run a quick Terraform destroy to make sure I don't forget to do that. So I'm tearing down that cluster. And I'll probably rebuild a new one straight away and see if I can recreate that issue. All right, well, we've got another meeting after this, Sean. So really, I just wanted to give you an opportunity to tell us if you had any interesting learnings from the whole process of building the eBPF data plane, anything you do differently or anything you learned that you thought was interesting. And there's no pressure if the answers that you haven't particularly got anything, that's totally fine too.
I mean, learned a huge amount by building it, mainly about BPF and its sort of strengths and weaknesses, maybe the wrong word, but like the things it's suitable for, the things it's not suitable for, like where you trade off, where you trade things off. I think the big learning was kind of like, yes, you can build something that's like performant in that, but it's not really like a silver bullet for performance. Like the way you get good performance is by sort of optimizing for your particular use case, and BPF is a great tool for allowing you to do those optimizations and to be creative, do different things to what the kernel would normally do for your particular use case, which, before BPF came along, you would have had to have written a kernel module or, taken advantage of something like DPDK to get packets up into your code rather than the kernel's code. Whereas BPF sort of sits kind of in between those two things and can integrate with the kernel a little bit more, but you can also customize your packet path quite a lot. Do creative things like preserve source IPs and things like that. It's what we were able to do. Of course, that comes with challenges too. So we're just working on some of the issues with that, where you have corner cases where preserving the source IP ends up with clashing connections downstream if the client decides to reuse ports and unusual things that you don't see too often.
Yeah, I imagine, although I don't fully know how much your involvement was at that point, but I imagine you must have been really grateful as you were implementing that data plane for the modularity with which Calico was built in the first place. That probably made it relatively it's certainly not easy, but easier to implement a separate data plane in the first place. Is that fair?
Yeah, I mean, we certainly had the data plane split out as a chunk of code, and the BPF data plane builds on that. So it sort of reuses a bunch of modules in the code, but it runs kind of, either or with the IP tables piece. So yeah, we're able to sort of reuse all of the upstream kind of calculation logic, and then the data plane being kind of abstracted means that we just had to re-implement that piece, and we can even keep some of the pieces of the data plane that are needed in either case. So the routing, all the routing logic is the same between the two. We program the Linux routing table, so Linux is aware of where the workloads are and that kind of thing. And all of that logic is just the same in both.
Yeah, which probably partly helps to explain why. I mean, because it's remarkable that you've built something as kind of high quality and stable and good quality code in a relatively short amount of time. So
I'd say the other thing behind that is we have suites of conformance tests for Calico. The Kubernetes end-to-end tests, our internal functional verification tests, and a bunch of other end-to-end and system tests that we have all automated. So a big part of the effort was porting those to run, setting up the jobs so that those jobs all run in BPF mode as well, and fixing issues that we hit in that. So by the time we release the code and mark it as GA, it's running in all those environments. It's running in AWS, it's running in GCP, it's running on Azure, it's running in OpenShift. We're testing it in all those environments routinely, and putting it through its paces with various tools. So yeah, that's how we build something that's pretty stable.
Yeah.
Even that said, I mean, it's still newer than the other technologies that we're using, so it still has some issues that we're working through, and but nothing that we can't solve, I think.
Cool. All right, well, I think that's a really good place to leave it. We're expecting another meeting, so let's wrap there. I think. Thanks again, Sean. I've really enjoyed doing these sessions, and I look forward to seeing you in the audience when we do cases.
Oh yeah, I won't heckle at all, I promise.
Yeah, I will. I'll throw you out, or whatever the YouTube equivalent of throwing someone out is. All right, thanks, Sean. I'll speak to you later on.
Bye, Ron.
Take care.